So now moving to calculus, let's do number 7. The first one says, given that g of x, which is 1 minus 4x squared, determine f of x, f prime x from the first principle. So what is f of x of the first principle? This is the equation or the formula. So the first thing that we need to do, we need to find f of x plus h, then we need to find f of x. So let's start with f of x. It's going to be equals to this g of x. Then f of x plus h basically is wherever we see x, we're going to substitute by x plus h. Then here we need to simplify, so we're going to have to expand this side. Then we're going to have to distribute the negative 4. Then basically we're done with f of x plus h. Then the next step, I'm going to take f of x, I'm going to take this numerator basically, which is going to be equals to minus, always put the f of x in bracket, the f of x in bracket, distribute the negative sign. Then what you're going to see is negative, positive 1 and negative 1 are going to cancel out, and negative 4 and positive 4x squared are going to cancel out too. So you're going to be left with, always take out h as a common factor, and the goal here is always to take out h as the common factor. That's what you want from this step. Take out just h. Then you are done with this step. So what you're going to do is you're going to substitute this here in the numerator, because of this and this is the same thing. So let's do that. What do you see? We see the fact that we have h in the numerator and h in the denominator. So they're going to cancel out. So you're going to be left with, now we're going to substitute the h here. When you substitute, the limit drops. So therefore making your answer. So therefore f prime is equals to negative 8x. 7.1.2 says, has calculate the gradient of the tangent of f at x is equals to 2. So we know the fact that the gradient, remember that gradient here is equals to f prime of x. We already know what's f prime of x. We got it as negative 8x. So we need to find the gradient at the point of x plus 2. So we're going to substitute 2. So we're looking for f prime of 2 is equals to negative 8. 2, therefore, it's going to be equals to negative 16. And you're done with this question. 7.2 says, determine f prime if f of x is equals to this equation, to this function. So we know that f of x is equals to 3 square root of, and we need to find the first derivative, right? F prime. So what I need to do is I need to write everything in exponents form, and this denominator needs to go, this exponent x to the power 4 needs to go to the numerator. So let's do that. This one's going to change into being 2 divided by 3, right? Then to move this one to the numerator, this positive 4 is going to be negative, so it's going to be 1 over 4 x minus. So now we're going to find f prime. We're going to take the exponent here and put it in the front. Then take this part and minus it by 1. Plus take this exponents, multiply 1 over 4. So we're going to take it in the front. So it's going to be 1 multiplied by negative 4. Then we're going to subtract this one by 1. Simplify that. You can leave your answer like this, or you can further simplify it, which is your answer is going to be. And this will be your final answer. With this one, you're going to still get your full marks. Question 7.3 says, given h of x is equals to ax squared, then they tell you the fact that x needs to be greater than 0. Then they say determine the value of a if you are given that f inverse function when you substitute a is equal to f prime of 4, yeah, when you substitute 4 inside. So what we're going to do is, we know the fact that h of x, right, is equals to ax squared. So we're going to first find the inverse graph. So to find the inverse graph, this one needs to change into being y is equals to ax squared. Then finding the inverse, you swap x and y, right? So here it's going to be x and here it's going to be y. So you're going to say x is equals to y squared. Then from here you need to make y subject of the formula. So we're going to divide this side by a, divide both sides by a. So here the a are going to cancel out. So you're going to be left with x divided by a is equals to y. Then square root both sides to get rid of this square. So you're going to have square root of x divided by a is equals to y. Therefore, this is the same as h inverse of x is equals to the square root of what? X x divided by a. So we found the inverse. But one important information they told us the fact that h inverse when you substitute 8, right? So let's do that. Let's substitute 8. So wherever we see x, we're gonna put 8. So we're done with this first part, right? So we're done with this one. So now we need to find f prime. So we have our equation, which is h of x is equals to ax squared. Then they tell us that f prime, let's find f prime first. It's going to be a, take the 2 in front, so it's going to be 2 multiplied by x. Then at the top it's going to be 2 minus 1. Simplify this, it's going to give me 2ax, right? Then this is f prime of x. But we know the fact that f prime of 4, so we need to substitute 4. So that's f prime of 4 is basically equals to 8a. So important information, they told us that these two are equals to each other. So let's equate them. We know the fact that f inverse of 8 is equals to f prime at 4. We already have f inverse at 8, which is, and this one is 8 at a. Let's simplify this because we need to determine a. So we're going to square both sides basically to get rid of the square root. So this side is going to be left with 8 divided by a, and this side is going to be 64a squared. Remember the fact that when we square here, it needs to be distributed in both values, right? So now cross multiply. So this side is going to be 8 is equals to 64a cubed, right? So I wanted to get rid of the a here. Then divide both sides by 64. So this side is going to be 8 divided by 64. And here 64 is going to be cancelled. So it's going to be 8 cubed. This is going to be the same as 1 over 8 is equals to a cubed. Cube both sides. So you're going to have, so therefore making your answer a is equals to a half. Then you're done solving this question. So now let's move on to question 8. It says consider the graph g of x. Then they give you like a cubic graph. Then h of x, which is equals to this one, which is a straight line, right? So the first question says determine whether the graph h intersects the graph at g at its point of inflation. Then they say show all necessary calculations, right? So first we need to find the point of inflation. So what is the point of inflation? Is basically equals to the second derivative and it's equals to 0. So that's what it means, right? So we need to find the second derivative. So we have g of x here. Then we need to first find the first derivative, which is we take the 3 to the front. Then here it's going to be what? It's going to be 3 minus 1. Take the 2 to the front. So it's going to be 3 multiplied by 2. And it's going to be 2 minus 1. Simplify that. That's the first derivative. But you need to find the second one. So let's find the second one. So now we're going to take the 2 in front. Then subtract it by 1. Then same thing. This is like a 1. So take the 1 in front. Then subtract it by 1. Simplify this. So as I said, the fact that the second prime is equals to 0. So this side is going to be 0. It's equals to 6x minus 6. Take the 6 to the other side. If you divide both sides by 6, you're going to get x being equals to 1. But very important, the question they said point. Point contains the x and y coordinate. We already have x, so we need to find y. So to find y, we take this x is equals to 1 and substitute it here in the original formula. So therefore, it's going to be equals to, so making our point of inflation equals to 1 and negative 2. So remember, this is the point of inflation. But remember that in the first question, they said the fact that we need to basically check that the point of inflation is where g of x and h of x intersect. So now we need to check whether our x here, our x is equals to 1 here at h of x, is it going to give us what? Negative 2. If it does give us negative 2, then the points of inflation and the intersection are the same. So let's do that. Let's find h at 1. So when we simplify this or put this in the calculator, we're going to get negative 2. So we find the fact that at g at 1 and at h at 1, both of them are equals to 2. Therefore, to conclude this is that h intersects the graph of g at its point of inflation. Then you're basically done with this question. So now let's move on to 8.2. It says determine the stationary point of y is equals to g prime, the first derivative. Then they say classify the stationary point as either being maximum or minimum, right? So first they say y is equals to what? To the first derivative of x. In the first question, we already found what's the first derivative of x, of the first derivative of g. So we know the fact that y is basically equals to what? To 3x squared minus 6x. So this is the first part, right? We know that this is what? The stationary point. We need to substitute here what? The point of inflation, the x1. And we found the fact that x prime, right? The second derivative, which is the point of inflation, when it's equals to 0, we found that x is equals to, we already found that. So we need to substitute this one here, right? So let's do that. So y is going to be equals to, so basically what we're looking for, we're also looking for the turning point. So making our turning point, our TP, the coordinate, this is going to be the x1. So it's going to be 1 and -3. So that's going to be the turning point, right? So that's how you find the stationary point when y is equals to the first derivative of x. So now they say we need to determine whether this stationary point is what? It's a maximum or a minimum. So to determine that is that we need to look at what? At our function. This is what? This is a quadratic function. And when a is equals to 3 or a is positive, what does it mean? It means the fact that it's going to be what? A happy face. Remember from the theory of quadratic, I actually have a video explaining quadratic function. Since it's a happy face, do you see the fact that the turning point is where it's at the low, right? So meaning that the stationary point, which is the turning point, is what? Meaning that the stationary point is a minimum. Then you're done with this question. So now question 8.3.1 says, hence or otherwise determine the values of x which g is concave down. I'm gonna give you a few notes in pink. Concave down. You basically need to find this. The first derivative of x when what? When this is less than 0. Then concave up, this is down, right? Concave up is going to be the second derivative when this is greater than 0. So we need to find the first one for this question, right? So we know that the second derivative, right, is what? Is equals to, because we already solved it in the first question. Then now we're going to substitute this one here. So we're going to solve for x. So we know the fact that it's going to be 6 is going to go to the other side. Divide both sides by a as 6. So you're going to get x is less than. So that's going to be your answer. Then question number 8.3.2 says, determine the gradient of the tangent at the point of inflation. So when they say at the point of inflation, we know that the point of inflation, the x value is x is equals to 1. That's what this means. It means that at this point, right? And gradient, so for 8.3.2, gradient is equals to the first derivative. It's basically equals to the first derivative, right? So that's what we need to find. So we already know that the first derivative, right, because we have solved it in the top part, is equals to, so substitute x is equals to 1. So therefore equals to -3, which is the same as m is equals to -3. If you're noticing something, is that question 8.3.2 is exactly like 8.2. You get me? 8.3.2 it's the same thing as 8.2, but they asked it in different ways, but you're finding the same thing. So what can we conclude? We can conclude the fact that stationary point, when you're given the fact that the first y is equals to the first derivative, is the same as finding the gradient at that point of inflation. I think it's something that you need to link between the two, is that meaning stationary point when y is equals to the first derivative of a cubic graph is the same as finding a gradient of the tangent of g when x is equals to the point of inflation. So this is just one thing that I wanted you guys to see, but this will be your answer. So now let's do question 8.3.3. So it says a student claims that the gradient of g at any point will never be less than -3. Is the student correct or not, right? So gradient is a gradient at any point, right? So to understand this is that from the first question, finding the stationary point, which was the turning point, remember we found the turning point. Stationary point, we found the turning point, and we found that the turning point is 1 and -3, right? So here, since it was like we said the fact that it's minimum, meaning let's say that the point was here. I want you to guys look at this graph. The point of inflation is here, right? Then this is the concave up, right? So since it's here, it says the fact that gradient at any point. So if we find the first derivative negative and we find a gradient at any point here, right? It cannot be less than negative. It's because of why? At negative 3, that's where, see here at negative 3, that's where the graph turns and it changes from decreasing to increasing. So there isn't any number lower than that part. So meaning the students' claim are correct. I hope I'm making sense. Because of if you say the fact that there is any value, if we have a graph and we sketch it like that, right? Sorry, and we sketch it like that, there isn't any value lower here. The values end here at negative 3 because negative 3 is the Q value from the turning point. You get me? So since it ends at negative 3, like because negative 3 is the turning point, the student, his claims are, her claims or his claims are correct. So to conclude here is that since we know that Q is equals to negative 3, right? And Q determines basically the maximum and minimum. And since this is the minimum value, Q tells us the maximum or minimum. And since the minimum is negative 3, that means that the student is correct because Q is equals to negative 3 is the minimum, meaning that it can not go below negative 3 because there isn't any function under negative 3. See, it only ends here, then it goes up. So that's what it means. So now moving to 8.4. So it says determine the value of K if the graph G shifts. So we know the fact that there's going to be a shift, right? And we're going to check which type of shift it is when we look at basically the function that contains K, right? Then it tells us the value of X. That's so that the value of X for which the new graph is P of X, right? Then it has X plus K. Then it has X plus K decreases is between negative 3 and 1. So let's look at the information properly, right? So we know the fact that our graph is going to be decreasing, right? And that we have P of X. We have our new function, which is P of X. We need to check what is K here, right? If we have a function, this type of function, if the value that's inside the bracket, this is the P value, meaning this is what the horizontal shift. So this is the horizontal shift. So it moves the graph left and right. So K is going to affect the graph by moving it left and right, right? So we need to check how much does it move it left and right. So we have established that K is P, right? So we need to link P and G first. See something is that we have G of X as being what? As being equals to X cubed minus 3X. That's what we know, right? But look at something. Isn't G and P similar? They're very similar. The difference between G and P is that at P here inside at X is just going to be X plus K. So P of X is the same as G of X plus K. Do you see that? Which is equals to what? Which is equals to this one, which is X. Since we've made the link between P and G, we can move to the next part. So they tell us that both the graphs decreases, right? What does it mean when graphs decrease? Decrease means that G and P decreases, right? When they decrease, it means that G prime of X is going to be what? Less than 0. So let's substitute. We know the fact that was G of prime. We know that G of prime is equals to, because we solved it in the first part. Then here you need to solve inequalities, right? So we need to find our critical values. So to do that, we need to factorize this side first, which is going to be, so making our critical values being, then we're going to draw a number line. Then you need to pick a number between, you need to plot 0 and 2. So let's do that. Put a straight line like this just to indicate it. Then we need to find any number between negative infinity and 0. Let me pick negative 1 here. Then we need to find any number between 0 and 2, which is I'm going to pick 1. Then here I need to find a number between 2 and positive infinity. I'll pick 3. Then substitute them where at this first derivative here. We're going to substitute it here. Then after substituting negative 1, positive 1 and 3, we find that it's 9, it's negative 3 and it's 9. So we only concern about the sign. So the first one is positive, negative and positive. Then we're going to put them in the respective respective places. So here it's going to be positives, here it's going to be negatives, and here it's going to be positives. So less than, right? This one means when it says that f prime of x is less than means what? It means negative. So we need to find on the number line where it's negative. So where is it negative? It's negative between 0 and 1, 0 and 2. So our inequality is going to be that x is between what? Is between 0 and 2. So that's the inequality for this, right? But remember this, we need to find the inequality for p. But p, they already tell us the inequality in the question. They say p of x, then they give us the function decreases, is between negative 1 and 3. So we know the fact that what? That for p of x, right? P of x, when it's decreasing, is the same as p of x is less than 0, right? So p prime of x is less than 0. So they tell us the fact that this is basically equals to x plus k, right? Here substituting x by x plus k. They tell us in the question that it's between negative 3 and 1. So here it's negative 3 and here is negative 1. But if we take this k to the other side and make x alone, this and this are going to be equal. So let's do that. So if we say x and take this k to the other side, it's going to be negative 1 negative k, and also this side is going to be negative 3 negative k, right? So we see the fact that here is x and here is x, so we can equate the sides together because the inequality is the same to solve for k. So we're going to say for this side it's going to be 0, right? My 0 is going to be equals to this, which is negative 3 minus k. Take this negative k to the other side, so k is going to be equals to what? To negative 3. So that's this side. Let's check whether what's going to be k on this side. Equate this negative 2 by this one, which is going to be negative 1 minus k is going to be equals to 2. Take this negative 1 to the other side, is going to be positive, so negative k is equals to 3, therefore k is equals to negative 3. Do you see the fact that now we know that k is equals to negative 3? So let's go up from the first part. Since k is negative 3, what does negative 3 means, right? Negative 3 means that the graph is going to shift to the what? To the left. So conclusion, right? The graph, conclusion, since k is equals to negative 3 and basically g and p is the same thing, the difference is k, is that the graph g, right, is going to move to the left. So since it's negative, g is going to move to the left, and that's that. So now let's do question 9. It says the bracelet below is beaded by using 10 plastic spheres and 10 plastic cylinders, right? When completed, the bracelet will be painted. Ignore the holes in the sphere and the cylinder. The following formulas are given, so they give you the volume, right, of the cylinder, and they also give you the volume of the sphere. So let's write which one is the cylinder and which one is the sphere. So the first one, right, this one, this is the volume for the cylinder, right? This is the volume of a cylinder, and this one is going to be what? It's going to be the surface area of the what? Of the sphere. Then this one is the volume of the sphere, and the last one, which is I need to correct, is the surface area of the cylinder. The one that they gave you guys here is incorrect. It needs to have r here, so let me have it's 2 pi r squared plus 2 pi r, so add an r, right? So now the bottom part, they say the following essential properties of different beads are, then they tell you that the radius, the radii, which is I, of the sphere and the cylinder are exactly the same. Very important to know. Then they say the height of each cylinder is h, so we know that. So now we know the fact that r here at the volume and r at the cylinder, r at the sphere and r at the cylinder are exactly the same, right? So the first part of the question, they say the volume of the cylinder is 6 centimeters per cube, right? Write down h in terms of r. So what is the volume of the cylinder? It's gonna be, I said it's gonna be this one. So we know that volume is equals to what? 2 pi r squared h. But they they tell us the fact that this one is equals, the volume is equals to what? 6 centimeters cubic, right? So it's going to be 6 is equals to what? 2 pi r squared h. Then we need to make h the subject of the formula, so I'm going to divide both sides by pi r squared. The pi r squared are going to cancel each other, therefore h is going to be equals to 6 pi r squared. So you're done answering the first question, right? Then question 2 says, show that the total surface area as of all, remember, all painted surfaces of the bracelet is equals to this. So we need to find the total surface area, no? So the total surface area is going to be equals to, remember, we have 10 of the sphere of the S, right? So we have 10 of the, so we need to take 10 of the sphere, because it's 10 of them, the surface area, so which is going to be 4 pi r squared plus what? Plus 10 of the cylinder, which is 2 pi r squared plus 2 pi plus 2 pi h r, right? Distribute the 10, so it's going to give me 40 pi r squared plus 20 pi r squared plus 20 pi h r, right? Then let's simplify this. 60 pi r squared. Then this one, since we wanted in terms of r, right, we need to substitute the h by r, right? So let's do that. So it's going to be plus 20 pi r, right, and h we're going to substitute it by this one, the one that we found here, which is the volume, which is going to be 6 pi r squared. Let's simplify this bottom part. So since everything now is in terms of r, we can say s open bracket r is equals to 60 pi r squared. Then let's multiply numerator to numerator, so it's going to be plus 120 and then pi r divided by this one multiplied by this denominator, which is 1, is going to be pi r squared. So this 120 is going to remain the same. The pi and the pi are going to cancel, and here it's going to be remaining with just 1 r. So this one is going to cancel. So we're going to have s r is equals to 60 plus 120 divided by r. So you are done with the second part. So question number 3 says, determine the value of r so that at least amount of paint is used, right? So we need to kind of find like first derivative. So let's do that. So we know that the surface area here is, now change this one and take it to the top, because we need to find the first derivative. Then now we need to find the first derivative. Take the 2 in the front, then subtract the 2 by 1. Then same thing, take the negative 1 in front, then subtract it by negative 1. Simplify that. The first derivative, when we're finding the at least, we need to make this equals to 0. So it's going to be 0 this side. Then this side, I'm going to change this negative 2 and take it to the bottom, so I can solve for r. So it's going to be 120. Then I'm going to take this one to the other side, then multiply this. I want to get rid of the the r squared, so I'm going to multiply this one this side by r squared, so it's going to be 120 is equals to, simplify this, take this 120 pi to the other side. So now the 120 are going to cancel out, so you're going to be left with 1 over pi is equals to pi cubed. Cube root both sides, the side are going to cancel, so r is going to be equals to, so this is the at least radius that you need. So that's the final answer.